Okay, so this should be a little easier, I hope. This is the function graph. Here, let me do this. This is now not the function graph. So find the period, the amplitude, period, and phase shift of this function. Yeah, you were. Do you know why you were right, Ramon? Or did you just get lucky? That was right. Okay, well, that was pretty good luck. I don't know how you did that. Hold on, wait. Hold on. I'm trying to cover up this graph. Because, oh, well, that was, okay, it's fine. Now you know. That's all. Okay, so we have our phase shift. I mean, we have our function. And we want to find the amplitude. So what's the amplitude? Okay, so what's the amplitude? There you go. Amplitude's always positive. So all your -2s were kind of right, but it's positive too, right? What is the period? Yes, very good. The period is pi over 2. So why is it pi over 2? Here's what we're going to do. We're going to put this, well, I'll do it in a minute. So, and then the phase shift. What's the phase shift? Okay, so here's what we want to do. So a lot of you are right. We have to change this into the shifted form. So we're going to factor out the 4. And we're going to say this is x minus pi over 4. So this is my A, this is my B, and this is my C, right? That's my amplitude. This is my phase shift. So my phase shift is, actually it's pi over 4, not minus pi over 4. Because it's going to the right. We're shifting to the right. If I'm shifting to the left, it's minus pi over 4. My period is equal to 2 pi over b, which is 2 pi over 4, which is pi over 2. Okay? Questions? Okay, good. And then the graph would look like, I'm not going to erase it all, but here, I guess I can. So the graph would look like this. Okay? Actually, That's not shifted. The amplitude is always positive. This graph is not right. Does everybody see that this graph is not right? Oh, okay. Never mind. It might be right. Hold on. It is right.
Shifted by a full pi.
Yeah, you're right. So it's shifted. This graph is correct. So it's shifted by, yeah, it's shifted by pi over 4, which is actually, okay, so let's see. Yeah, this graph is right. We'd have to go through the whole thing to see why this graph is right, but it is right because it is shifted. Hold on, it's not. Okay. So remember that this is negative. Because this is negative, the original graph would normally go like this. It would start at -1. So this is our shift right here. It's shifting pi over 4. Do y'all see that? Because of the -2. Okay? Who doesn't understand what I just said? Sure. So I have my, it's not, they're not associated. So I have my normal graph. So remember, you have to understand what the normal graph looks like. So the normal graph of sine would look like this, right? So this is, this is, oh, sorry, we're doing cosine now. Okay, so this is the cosine graph. Starts at 1 and continues through. Okay, so this is cosine. Okay, now we have minus cosine. Does everybody see that? All right, so if I'm looking at -2, then what I'm looking for is this point right here would normally be associated with this point at the axis, isn't it? Is everybody with me? So this point that should be here, if it were a regular graph, has been shifted pi over 4 to the right. Okay, does everybody get this? Any questions? Okay. Oh, let's see. What's more shifting? I just want to see how many more things I have. We did that one. We did that one. Okay, we're almost done. Let's do this one. So we have a population of an animal species to be modeled by the function P of t equals 1200 cosine pi over 5t plus 9,000, where P of t represents the population in year t. So find the period. What's the period? Jackson, what's the period? Two pi over b. What's b? Good. Pi over 5. So that means that p, my period, is equal to 5 over pi times 2 pi, right? Which is 10. All right? Let's not graph it for a moment. Let's do C. Find the maximum and minimum values. So, let's see. John Medina. What's the maximum value for this function? No. You have any other ideas? How about John Moorhead? No. No. How about Jonathan Hom? One second, Michael. Let me see if Jonathan knows. No. We're not putting random numbers in. I will never have you putting in random numbers. That's not really math. No, Lewis, don't answer. I'm asking you please not to answer if I don't call on you, Louise. Please. Okay? Please. You got to stop. Okay, Michael, what do you think the answer is? Good. Thank you, Michael. Exactly. So remember, perfect answer, perfect reason. So we have our regular cosine graph, but our amplitude is 1200, right? To 12. And then we take that graph and we shift it up 9,000. So that means we have the maximum is going to be 9,000 plus 1,200, which is 10,200. Okay, perfect. What's the minimum value? Michael, you can finish since you did such a good job. I love all of you guys. Y'all are great. Listen, I'm just trying to get you to interact. It's real important. If I don't recognize that you're here, some of you think I don't know you are, so that's why I'm calling on you guys. I know you're here. And you matter. I don't think so. Try again. Yeah, Brian. So remember, the minimum value is going to be minus 1,200. Good job, Brian. You're on your cell phone too, see? It would be 9,000. So this is also getting shifted up 9,000, isn't it? So it's 9,000 minus 1,200, which is 7,800. So, okay, so that's one way to look at it. Another way to look at it, so does everybody get that? That's like the visual of it. Okay, so now thank you. So here's another way you can look at it. Ready? What's the maximum value cosine can be? Maximum value cosine can be ever 1. So that means cosine here, the maximum it could be is 1, which would make this 1,200 times 1 plus 9,000. This is the algebra part, not the graphic part. Okay? What's the minimum that cosine can ever be? Minus 1. So I'd have 1,200 times minus 1 plus 9,000. So that's my maximum and minimum. So I like the second one a lot because it makes you understand the actual range of the cosine. But both ways are really good because one's the visual graphing part and one's the algebra part. So are we all good?